So before we can move ahead to solving logarithmic equations, we still need some practice using their properties. And right now we're going to talk about our property of converting from a logarithmic form to an exponential form and vice versa, going in the other direction. So here we have an example. We have a logarithmic equation and we want to convert this to an exponential equation. What we want to remember and what we know is that log base b of our argument a will equal our output c. And this can convert or change forms and become b to the c equals a. So if I want to convert this, this is going to become, my base is 2, so I have 2. My c value is 3, so 2 cubed equals, that original argument was 8. So this represents the given logarithm now in exponential form. So let's do 2 more examples of this. My next example here, log of 0.01 equals -2. So this is the same, since it's a common log and there's no base written, it's the same as writing log base 10 of 0.01 equals -2. And this can be converted 10 to the -2 equals 0.01. So this is my converted form. And of course this should make sense to us because 10 to the -2 is 1 over 10 squared, or 1 over 100, which is 1/100th. So let's see. Here we'll do another example. The natural log of 30 equals 3.4012. So this is a natural log. Remember, a natural log is base e. So this is the same as writing log base e of 30 equals 3.4012. Converting that, remembering that what we have here, log base b of a equals c, is going to change to b to the c equals a. So doing that, I'm going to get e to the 3.4012 equals 30. And this is a true statement. However, if you type this converted form into your calculator, you're not going to get exactly 30. If I type that into my calculator right now, e to the 3.4012, I get out 30, e to the 3.4012, I'm going to get out 30.000078855. And the reason this was in order for me to even do this problem and write that value on my paper, the 3.4012, I had to round it, okay? So it's not exact, but this is how that form would work. And so while we're talking about this, something that's really important to acknowledge is that natural log of 30 is an exact way to write this approximate decimal, 3.4012. So moving ahead in mathematics, I'd really prefer ln 30 to be written on our paper instead of the answer 3.4, 3.40, etc., because that's going to be a rounded approximation. Let's do one more of these. Let's do this example. So log base 2 of 5 equals 2.32193. Okay? So if I wanted to convert this, this would turn into 2 to the 2.32193 equals 5. So we are going to convert the exponential equation to logarithm form. And for our first example, we're given 125 to the 1/3 power equals 5. Over here on the right of the screen, I've written our conversion formula. We can convert exponential to logarithmic. So keeping this in mind, this is the same as writing b to the c equals a, which converts to log base b of a equals c. Stay consistent with our colors. So this becomes log base 125 of 5 equals 1/3. So let's do another example. E to the 3 equals x. So e to the 3 equals x, that's going to become log of my base, which is e, and that would be of x equals 3. So my base was e, my c value was 3, moved to the other side of the equal sign, and then x represented by a. Now, when we have log base e, we prefer to write ln. So log base e is ln, so I'd rewrite this as ln x equals 3. And we'll do one more example. Q to the r equals p. So how would I convert that into a logarithm? Remember, if we have b to the c equals a, then that is going to become log base b of a equals c. So my b value is q. I've got log base q of p equals r. So the main thing we want to remember here is we want to know, we want to feel comfortable changing forms. And the only way to get better at this is practice.